So how do I solve a complex problem? First, you need to understand it well. In problems in the AI domain, there exists the notion of a dichotomy between the inside and the outside. In reinforcement learning, you have an agent and its world. You'll need to analyze both, the inside and the outside, in detail. Nature of the problem. What are the different aspects of your problem? Is it primarily data-driven, i.e., does data take foremost precedence in arriving at a solution? Or is it principle-driven, i.e., algorithms, methods, and techniques are primary? Or is it knowledge-driven, where the central aspect is formal or expert knowledge? Aspects you need to consider include customization, scaling, specialization, etc. A common point of pain, dealing with having to build a black box. If so, can you avoid it? If not, what do you do? Nature of the world. World definition advises problem definition. If the world is partially visible, the model may have to maintain memory of some sort to remember the parts of the world it has encountered as seen as system state in planning and RL. Aspects you need to consider include visibility, multitude, uncertainty, etc. Decomposing. Once you've understood the problem and the world, it's time to break it down into subproblems. A common way to do so is by hierarchy inherent in the problem. In NLP, are you modeling letters, words, sentences, paragraphs, sections, or documents? Okay, I've decomposed my problem. Now what? First, you hypothesize a solution for every subproblem. In order to do so, you need to understand your method/technique choices. Specifically, which methods can stand in or replace what others? You need to ponder interchangeability. How do methods extend others? How can two or more be combined together to solve a problem? Also, if there exist patterns where methods are combined together, you would need to know that. If you have the model of an individual, how would you scale that up to study a crowd? Armed with knowledge of interchangeability, integration, and patterns, you can now architect your solution. As a principle, avoid solving complex problems with a single large, deep net. Instead, perform these steps collaboratively. 1. Draw a flowchart with the different functional parts of the solution. If you are modeling a crowd, for example, you potentially have 3 steps. A. Model an individual. B. Model a crowd. And C. Model behavior. 2. In the flowchart, apply a method to each function. In the above, you could have A. Supervised learning, B. Discrete event simulation, and C. Agent-based simulation. 3. Now, select a technique for each method. A. Linear regression, ML, B. SymPy/AnyLogic, DES, and C. Wasabi/Gamma, ABS. Sometimes there may be more than one. This is how you hypothesize an architecture. Include metrics and measures to validate performance both during training and operation. With that, not only do you now have your initial solution concept, you also have a structure that will let you swap methods and techniques based on how well they work for a problem. In order to solve a complex problem, decompose it into subproblems, select your methods and techniques, and assemble them in an architecture along with the appropriate metrics. Kado AI.